Welcome to FrontEndSystemsLab. This is a channel where we explore what's really going on under the hood of modern web development. Chapter 1. For the last few years, developers have been treating large language models like magical chat boxes. Type a sentence, hope the AI understands what you mean, regenerate the output, rewrite the prompt, add more context, paste more documentation, increase the token window. Somehow this entire workflow became known as engineering, but something massive is beginning to happen beneath the surface of the AI industry right now. Developers are starting to realize that natural language prompting was never the final interface. It was only the temporary bridge between humans and probabilistic systems, because the deeper issue is not model size. It is not context length. It is not even intelligence itself. The real problem is language. Language is ambiguous. Compilers are not. And once you understand that distinction, you begin seeing why recursive syntax trees may completely replace traditional prompting for serious software development. The entire prompt engineering movement was built around one assumption: that humans should communicate with machines using natural language instructions. At first, this felt revolutionary. You could ask for a React app, generate APIs, create SQL queries, explain algorithms, build interfaces. It felt like programming itself was dissolving into conversation. But then production reality arrived. The larger the systems became, the more unstable the results became. Small inconsistencies started compounding into catastrophic architectural drift. The model forgets earlier constraints. It rewrites working logic. It changes naming conventions halfway through generation. One small modification breaks unrelated systems. Developers started adding more prompts trying to stabilize the outputs. More instructions, more context, more examples. More warnings saying, do not modify this section. This created another problem entirely: token bloat. The industry convinced itself that bigger context windows would solve reasoning. But context size is not intelligence. It is only larger temporary memory. And memory without structure eventually becomes chaos. This is why two nearly identical prompts can still produce completely different outputs, because natural language itself is fundamentally probabilistic. Words carry ambiguity. Intent shifts based on phrasing. Context changes interpretation. Human conversation tolerates ambiguity extremely well. Software systems do not. That is the wall the industry is beginning to collide with right now. Developers do not actually want conversations with machines. They want deterministic execution, and that changes everything. Chapter 2. The biggest misconception about large language models is the idea that they are truly reasoning the way humans reason. Most of the time, they are performing probabilistic token continuation. They are predicting likely sequences based on learned statistical relationships. That works surprisingly well for conversation, but software engineering is not conversation. Software engineering is structured logic, dependencies, scopes, hierarchies, constraints, relationships, execution flow. Traditional prompting forces all of that structure into flat linear language. That is incredibly inefficient. Imagine trying to describe an entire operating system through paragraphs instead of architecture diagrams and compiler trees. That is basically what prompt engineering has been doing. Recursive syntax trees completely change the interface. Instead of describing logic through vague semantic instructions, developers can directly map structural intent into machine-readable hierarchies. Not please create a reusable authentication system with validation and modular routing. Instead, the system receives structured recursive relationships: authentication node, validation subtree, session management branch, permission inheritance layer, database adapter relationships. Now the model is no longer guessing intent from human phrasing. It is traversing logical structure directly. That is an enormous shift, because software itself is recursive by nature. Functions contain functions, components contain components, systems contain subsystems, scopes contain deeper scopes. Modern software is hierarchical all the way down, but natural language prompting flattens hierarchy into sentences. Recursive trees restore the hierarchy directly into the inference process itself. That means the model can reason about relationships instead of merely predicting adjacent words, and this dramatically reduces hallucination, because many hallucinations are not random mistakes, they are structural drift. The model loses track of logical relationships over extremely long token chains. Recursive syntax trees anchor those relationships in stable architecture. Instead of generating code linearly from left to right, the model traverses a logical map, much closer to how compilers process abstract syntax trees. And that leads to one of the most important advantages of all: compression of intent. A recursive tree can represent enormous architectural meaning using far fewer tokens than natural language explanations. That means smaller context loads, lower inference overhead, more stable generations, better scalability, better orchestration, and most importantly, reusable systems. Developers can begin reusing structured logical architectures instead of endlessly rewriting prompts trying to force stable behavior out of probabilistic systems. That changes AI development from chatting into actual software architecture. Chapter 3. This is why many researchers and advanced AI tooling companies are quietly moving toward graph-based reasoning systems, symbolic augmentation layers, recursive planning structures, constraint-driven generation, compiler-integrated inference pipelines. Because the future interface is probably not a chatbot. It is an orchestrated logic engine. Prompt engineering itself may eventually become viewed the same way we view assembly programming today, still useful sometimes, still flexible, but increasingly inefficient for large-scale engineering. Natural language prompting was always a temporary adaptation layer. It existed because humans needed a bridge into probabilistic models. But eventually, every technology evolves towards structured abstraction. Assembly evolved into higher-level languages. Manual infrastructure evolved into automation. Machine instructions evolved into compilers. And now prompting itself appears to be entering that same transition. Recursive syntax systems move the intelligence into architecture itself. The developer no longer micromanages wording. They define logical topology. That creates something dramatically more stable, deterministic orchestration, not perfect certainty, but far less ambiguity. And once AI systems become structurally aware instead of purely linguistically reactive, the entire development workflow changes. You stop asking the AI for code. You begin constructing executable reasoning frameworks. That is an entirely different paradigm. And this shift may happen faster than most developers expect. Because once engineers experience architecture, aware generation going back to fragile prompt guessing starts feeling primitive. Very similar to how manually writing assembly eventually became unnecessary for most software developers. The companies that figure this transition out first will probably dominate the next generation of developer tooling, not because their models are larger, but because their interfaces become structurally intelligent. That is the real race now, not bigger models, better orchestration. Chapter 4. Natural language prompting was never the destination, it was the training wheels. The real transformation begins when artificial intelligence stops behaving like a chatbot and starts behaving like infrastructure. Recursive syntax trees may be one of the first major steps toward that future. Because the future of software development is probably not about talking to machines. It is about architecting cognition itself. And the developers who understand that shift early may end up building the next generation of computing. Thanks to you for watching FrontEndSystemsLab. Please subscribe for more under the hood content.